Welcome, GeoTrig. This is section 6.1, the Polygon angle sum theorems. The essential question is, how do you find the sum of interior and exterior angles of a polygon? Let's begin. So just a little bit of vocabulary review, just in case you don't know these words. What's a polygon? Well, it's a closed figure with 3 or more sides, and the segments don't cross, and they're all the same plane. So yeah, some shape where the lines aren't going to cross. All right. Vertex. Vertex are corners of polygons. Vertices are the corners. So, in a few other words here, an equilateral polygon is when all the sides are equal, they're all congruent. An equiangular polygon is a polygon with all the angles congruent, and a regular polygon is a combination of both. All the sides are congruent, all the angles are congruent. Alright, so let's look at these shapes. I got a triangle, I got a square, I'll put a little square right here, and I got a pentagon. What do the interior angles add up to? The interior angles inside. And I know for a triangle they add up to 180. And for a square, well, each corner is 90, and 90 times 4 is going to be 360. But what about a pentagon? Maybe there's some pattern. And there is some pattern. And this is the pattern, the Polygon angle sum theorem. So the sum of the measures of the interior angles is n minus 2 times 180, where n is the number of sides of a polygon. So let's check that out and see if it's legit. So this is 3 sides, this is 4, and this is 5 sides. So if I plug in a 3 for n, I get a 3 minus 2 times 180, which is a 1 times 180. And that equals 180. That checks out. Well, for a square, it's going to be 4 minus 2 times 180. So 2 times 180. And that's going to equal 360. Yeah, that checks out. So I'm guessing this pattern works. Let's try the pentagon. So it'll be 5 minus 2 times 180. Or that's going to be 3 times 180. That is going to 180, please. And that's going to equal 540. Yep. So all the interior angles add up to 540 degrees in a pentagon. All right. We have the corollary to this Polygon angle sum theorem. And that means, that is, the measure of each interior angle of a regular polygon is the sum divided by n, the number of sides, which kind of makes sense. So if you had an octagon here, a stop sign, you had 8 sides. If there was a regular one, so all the angles are equal, you basically add up the total and you divide it by the number of things. It's kind of like the average. So for the stop sign, it'd be 8. So 8 minus 2 times 180 over 8. So you get 6 times 180 over 8. And oh boy, what's that? Well, 6 times 180, I can reduce things first. So I'm going to get a 6 is going to reduce to a 3, and that'll reduce to a 4, and the 4 goes into 180. How many times is that going to be? 25 plus 4, okay, 45. So 45. So you have 3 times 45, that's going to be 135 degrees. So every angle right here is 135 degrees. Every interior angle. Okay, another question. What do the exterior angles add up to? So the exterior angles are, if you kind of extended these lines, it's this thing right here. And extend this line, it's this one. Extend this line, it's this one. Well, if this was equilateral triangle and this is all 60, 60, and 60, well, it means these other angles have to be 120, 120, and 120. And those add up to 3 120s is going to be 360. Okay. What about for a square? Well, these are all right here. This has got to be 90. And then this one will be 90. And this one will be 90. And this one will be 90. So 90 times 4 adds up to 360. Now pentagons. I don't know. But maybe there's some kind of pattern here. Some kind of pattern that we can use. If that's 360, that's 360. Well, guess what? They all add up to 360. So the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. Doesn't matter what type of polygon you have. So they added up to 360 here, the triangle for the square, and they will for the pentagon. Awesome. So let's try some examples. Pause the video. Alright, what is the sum of the interior angle measures of a heptagon? A heptagon has 7 sides. So the sum of the interior angle measures, that's the interior angle formula, which is n minus 2 times 180. And our n in this case is going to be 7. So it would be 7 minus 2 times 180, which would be 5 times 180, which will be 4, carry a 1, 4, 940? Sure. 940. Yep, I'm going to go with that one. Wait a minute. Nope, that's not right. 0. That's going to be a 0 carry forward. It's going to be just 900. Straight up 900. Yay. All right, last one. Pause the video. What is measure of angle 1 in the regular octagon at the right? So it's a regular octagon. That means all the angles are going to be the same. All the interior angles are the same. If the interiors are the same, the exteriors must also be the same. So that means I have 8 exterior angles, and then I know that the exterior angles all have to equal and add up to 360. So guess what? 360 divided by 8, that is what I'm going to get. So if you divide that by 8, let's see. Got to do it this way. So that's going to go in 4 times 32, 45. So the answer is 45 degrees because they all equal that. And that's it.